Hello everyone, welcome to Dave. And in this video, I'm going to take you through the task of loan approval prediction with machine learning using Python. And see, this loan approval prediction involves analysis of various factors such as the applicant's financial history, income, credit score, employment status, and other relevant attributes, right? And by leveraging this historical loan data and applying machine learning algorithms, businesses builds models to determine loan approval for the new applicants, right? So for this project, for this video, we'll use this particular dataset, okay? And you can download the dataset from the Kaggle link, and I have given you the link in the description. All right. Now, before we get into the project, so these are the classification algorithm that we'll use in this video. So we have support vector classifier like SVM, we have logistic regression, and we have random forest classifier. Okay, so now let's get to the video. Okay, all right, so this is the dataset, right? And we have around 1000 rows, like 1000 entries, and we'll be having around 20 columns on which this application ID, which we'll be removing pretty soon, and we have this target feature or this target column of loan approved. So removing that, we'll be having around 18 independent column, which are the main important factor to figure out that if a person is eligible for a loan or not. Okay, and one more thing, you could see in this data set there are multiple cells which are blank, so we need to perform that missing values. So now let's begin. All right, so what I'll do, I'll open this. So the first step that we'll do, we have to import libraries, right? So I'll first open a cell, and these are the libraries that we'll first import. We need to import couple of libraries more, but we'll import that later. Okay, so Control Enter, and I have already installed those dependencies, so that's why I don't have to install it again. But if in your case, if you haven't installed this library, just simply install it with this way. Let me show you. Exclamatory sign, pip, install, and pandas. Okay, like that, numpy, matplotlib, cbon, plotly, scikit-learn, everything. Okay. All right, so let me run this again. All right, now we need to load our data set. So for that, simple tf would be around pd, which is the pandas, and we'll call our read csv, and the name of our file is loan approval.csv. So loan approval.csv, control enter, and then to check the dataset, df.head, and this will print the first 5 rows. Got it? Now there are a couple of things that we have to do. First, this applicant ID is useless, so we need to remove that. So df, what I use, df dot, I need to drop it, drop name of that particular column, so applicant ID. Okay, and then axis 1, enter, and then if I again print the df.head, you will see we don't have this applicant ID anymore. Okay, so after that, there are a couple of things that we have to do. First, we need to check how many null values do we have, right? So def will use is null, and we'll just print the total sum of that. So you could see for every column we have 50 null values, so we need to fill this null values so with a proper value, so that at the time of training it doesn't affect too much. Okay, and these are some pretty, and then we need to just get the describe, like about the simple description about the dataset. So here we have applicant income, co-applicant income, age, dependencies, career score, and these are the numerical values. And this describe function is showing me the numerical values description. So count, mean, standard deviation, minimum 25%, all these features. Okay, and these are just some basic thing that you have to do always. And finally, again, print df.info. This is to get the information about your whole data set. Okay, so to handle this missing values, what we'll do first, if you could see in this data set, you could see we have two kind of columns. For one, for numerical columns, and another where we have string or more of a categorical column, right? So we first need to divide these two columns. Okay, so that's why what we'll do first, we'll first divide it. So first, let's say I want to divide the categorical column. So categorical column, df dot, I'll use this select data types, and here, like what kind of data types column that I'll select, I'll use this include, and I'll pass an object. Okay, and third bracket object, and then I'll use columns. Okay, and another one, we need the numerical columns. So numerical columns, again we'll use df dot select data types, where we'll include integer and float. Now why we have used object, you could see over here. Let's say in this df dot head, which is the categorical column. The categorical column is this, say this loan purpose, property area, education level, right? If you see in the info part, you could see this employment status, marital status, this loan purpose, property area. Wherever we have used string value, these are the object values, and these numbers are this either float 64. Most of all they are float 64, because everywhere we have used this decimal point. Okay, so we'll run this cell, and now if I print the value of my categorical column, if I run it, you could see I have employment status, marital status, loan purpose, all those column with the values of object has been segregated. Okay, now again if I use numerical column, see all those numerical values. Okay, now the thing I have to do, I need to fill in the gaps, right? First I'll fill for the numerical values. Now for that we'll use a scikit-learn library which is called as simple imputer, which helps us to fill in that blank value with a constant or a pre-calculated way. If I have to make you understand better, let me just Google it first. Let's say simple imputer, right? Simple imputer sklearn. See, simple imputer is a class within scikit-learn's impute module designed to handle missing values in a dataset. So if we see, is there any example? Yeah, so see, they're importing from sklearn.impute simple imputer, and simple imputer they're filling the gaps with the strategy of mean. Okay, so same thing that we'll do over here. From sklearn dot impute, I'll import simple imputer, and let's say it will be numerical imputer, right? Then I'll call simple imputer, and the strategy that I'll be using will be, sorry, I'll be using would be strategy, right? There will be an R. Strategy will be mean. It's a median. right? And then I need to merge that with my whole df data frame. So df numerical column, here I'll add this. So my cat imputer, sorry, my numerical imputer, num imputer dot, I'll use this fit transform where I'll simply pass this numerical codes, right? So numerical columns. Okay. There is some error. Okay. Okay, it's done. Right. Now I'll just copy this one and I'll paste it over here, and I'll change this for my categorical columns. So cat, and the strategy will be different because I can't use median for a string, right? So that's why we'll use most frequent. Okay, most frequent, and I'll just change this numerical column up to categorical column, and this num imputer up to cat impute, and this to categorical column, right? Categorical. Then I'll run this. Here we go. Okay, so we have handled those missing values. That we have filled all the missing values with some values as per our numerical column and our categorical column. Now to check it, here if I run this isNull.sum again, you could see we don't have any null values anymore, and this is what we wanted, right? Alright, now it comes to our exploratory data analysis. Here we'll try to figure out different kind of relations among our data set, which will help us for our further process. Okay, now the first thing that we'll do, first let me just bring the data set quick first. Here you could see in this target column, like in this loan approved column, we have no and yes. So first let us figure out key how many no and how many yes we have through a pie chart. Okay, because this analysis is all about to figure out different kind of relations from the data set, right? So first let's understand that in that particular column how many amount of yes and no do we have. Okay, so with the df, let's say the column name is loan approved, and what do I have to do? I need to count its all values. So value counts. Okay, I'll run it. Okay, I'm having an error. It's saying none type object has no attribute value counts. Oh sorry, this I need to close the print statement first. Sorry, I need to cut it, and I'll be closing this right now. Okay, so the number of no we have is 702, and yes we have 297. Now let us create a pie chart from this data. Okay, now how we'll do that? For that we'll import plotly dot express as p. So let's say, let me create a variable as loan status. So loan status count here df, and my loan approved, right? Now then simple value counts dot, I need to add this reset index. Alright, now after that we need to add a different column. So loan status count dot columns, and here I need to add the loan approved and count, right? Now here I need to plot the chart, so plot the pie chart. Now how to plot it? First I need to have a variable, so figure for loan status. I'll call the px library. I'll use the function pi, under which I need to provide the parameters. So the first parameters will be loan status count, where I'm storing the count of the number of no and yes. Then the names, loan approved, the values will be as count, and title will be loan status distribution. Okay, and you can always yeah, first let us do that. Then what I'll do, I'll simply run it. So figure loan status dot, I need to use this function show. Okay, it's saying error, obviously this one, right? Okay, all right, so we got this 70.2% is no, you see, loan approved no, and 29.8% is yes. Okay, now this was the first plot. Now we have to plot multiple figures. So let's say one of the generic figure would be, let's say how many gender we have in this data set, like how many male and female do we have. Okay, so first that I need to first count the gender. So gender count, simply use so df gender, then simple, and these are some basic which are similar for FD counts. Okay, so I need to use counts, gender count, df gender count, everything is right. All right, now for the figure gender, I'll use px dot, I'll plot a bar graph, so bar, and then I have to pass the gender count, then I have to pass the x variable, which will be gender count dot index, then I need to pass the y variable, which is gender count dot values, then I need to provide the title, which would be in this case, let's say gender distribution. Okay, and finally simple, just to show it, fig gender dot show. Okay, enter, and you could see we have this many amount of gender. We have 621 male and 379 female. Okay, now we use that same kind of code to plot some multiple bar graph. Okay, let's say this one was for gender. Now I wanna make another one for marital status. Okay, marital status, gender count, it will be marital count. I need to change this one, marital count, and marital status distribution. Okay, run this. Okay, I'm still having some error. Sure, I need to got it right. Marital, and this one would be again marital. Okay, run this. Why still error? Marital status. So let me see the name in this. What is the exact column name? Okay, so the column name is marital status. Oh, the S should be in caps, so caps, enter. See, married single. Okay, now you can use this same kind of code to plot multiple bar graph. Okay, I'm not using for everything, but you can use it, but you can use this for educational level, employer category, all this kind of thing. Okay, so we have seen an example with pie chart and bar graph. Let me show an example with histogram. Okay, now how we'll do that? Histogram, again a pretty much simple one. First we will declare a variable as figure, let's say applicant income, and of course histogram have to be in the form of numeric value because it will plot multiple bar graph, right? So figure applicant income px, again the function is histogram. After calling the function you need to pass the whole data set. So df, you need to pass the x variable where you will be storing the applicant name, like the main column that you want to use. So I want to use applicant, like applicant income, right? And then you need to just provide the title. Okay, title would be, let's say, applicant income distribution. Okay, and finally simple figure applicant income dot show. Here we go. Let me make it small. Okay, see, this is a kind of histogram plot. Applicant income 10,000 to 11,000, all this thing. Okay, now you can use the same thing for plot another histogram, which is, let's, and this one would be for co-applicant, right? Co-applicant. I need to change this applicant, right? And let me just change this one. So co-applicant. Run this. Sorry, wait a minute. This one should be co-applicant, no? Okay, co-applicant. Okay, here we go. This one is for co-applicant income. Okay, so we have done with our pie chart, bar chart, histogram, and now one of the most important this kind of figure is the box plot. Now what is box plot and why we use that? If I have to tell you, let's say box plot in data analytics. You could see that in data analytics, a box plot is a graphical tool that visualizes the dataset distribution by showing its 5-number summary: minimum, first quartile, median, third quartile. So the main thing is we use box plot to figure out the outliers. Okay, if there is any example, let me just check. So yeah, this one, see. So this one, you could see this is the blocks. So sorry, so this is a box plot, this blocks and these lines, and this outside of that, this green dot, these are the outliers. I mean, these are the kind of the exception points. And in a data set, if we have multiple this kind of exception point like outliers, it affects our data set training in a pretty negative way. So it's a good practice to remove those outliers. Now this data set unfortunately pretty much don't have any outliers, but I'll still be showing you how to figure out the, like, how to plot a box plot. Okay, so to plot a box plot, what we do, first simply create a, let's say I'll be plotting this with applicant income and the amount of loan approved. Okay, so let's say figure income, I'll use px dot box plot, so box box. I need to pass the whole data set. Then for x variable, I'll use the loan, how much amount of loan have been approved, with the condition of, let's say, applicant income. Okay, so loan approved and applicant income. Then simple, I need to provide the title, which would be applicant, let's say applicant sorry, let's say loan versus applicant name, and then fig income dot show. Okay, let's enter, and this is the box plot. So it doesn't have an outlier, so we won't be using any outlier removal code. One more thing that you can use, you can add some color to it. So color, if I use, let's say, loan approved, right? Sorry, yeah, there gotta be an underscore, enter. Okay, so I just colored this loan approved yes1. So you can make it a bit of different color as per your wish. Okay, and you can also plot a box plot of loan approved with the corresponding to co-applicant income, or loan approved with the corresponding to loan amount, all these different kind of things. Okay, so after that we need to plot one of the most important um, figure, which is pretty important for loan approval understanding, which is the relation between a credit score and the rate of loan approval. Okay, and we'll use histogram for that. So let's say a figure with credit score. Okay, again px dot, I'll be using a histogram, so histogram. Here I'll pass the whole df dataset, and in x I use my simple credit score, and let's say I need to use some color because there will be multiple things. So let's say loan approved, and I also need to provide the bar mode, which will be in group. Why, I'll be telling you a bit later. Just let me plot it. Title would be, let's say, around approx loan approved versus credit score, because that's what we want to understand. Credit score. Finally, figure credit score. So figure credit score dot show. Okay, enter. X is not defined. Credit score, na? This C would be in caps. C in caps, and this X in also in caps. Okay. Okay. So you could see that credit score should be approx 650 plus to be able to approve your loan, and that's why this blue bar are for no, see, and this orange bar are for yes. So the credit score below 650, there is no orange graph because loan won't be getting approved. But the moment your credit score will be above 650, you see some multiple orange bar graph, which saying that there are some possibility of getting your loan approved. Okay, so this is pretty much one of the most important figure. We have showed this pie chart, multiple bar chart, histogram, box plot, and this histogram for this like group bar chart, right? You can plot as many as you can to get as many insightful data from the dataset. Okay, now we'll be moving forward with our encoding variables. Now what encoding means, simple as that. If I use this df.head now, df.head, you will still see that in my employment status I have salary, which are string like object. But the moment I'll be giving this data into my training model, I can't provide a string value. I need to provide with the numerical value, right? So I need to encode the string into a numerical value, and that's why we have two kind of encoder as label encoder and one hot encoder. Label encoder is mainly for binary categorical value like marriage, yes or no, so 0 and 1. And one hot encoding is let me first show you, then it will be easy for me to explain. So let's say from sklearn dot preprocessing. So preprocessing, I need to import two things, which is the label encoder. So I'm not getting the suggestion first. Label encoder, and another one is one hot encoder. Okay, now I'll create a variable as label encode, and here I'll call the function of label encoder. There we go. And then what I'll do, see, in this particular df.head, you could see we have this marital status and the what is the gender and this loan approved as a binary string, because these are only two options, right? So that's why we'll run a loop. So for column in this value, so we need to add the values. So marital status, gender, and the last one was loan approved, right? Loan approved if colon in df dot columns, then what we'll do, sorry, this one should be a colon. Okay, so within this for loop I need to use a tab. If df dot columns, then df of col, I need to call my label encoder, label encode dot, I'll use the fit transform, and I'll provide that particular column. Okay, so this one is done. Now after that we'll use for the one hot encoding, right? So this is the encoding. So this was the label encoder. Now for the one hot encoder, what we'll do, listen to our df and then pd dot to use our get dummies and get dummies, which will pass my df, and in the columns I'll use all of the, I'll add all the column which needs to, wait just a minute, columns which needs to be one hot encoded, right? So we have, let's say, employment status. So employment status, we have others, let's say loan, property area. We have educational, not status, we have educational, I think level, sorry, educational level, and then we have our loan purpose, employment status, property area, loan purpose, educational level, and yeah, employment category, right? Employment category, sorry, employment category. Okay, and then the first thing I'll do, drop first, so true. Okay, enter. There is some error, employment status. Okay, so pd dot get dummies, employment status not in index. Okay, I need to, let me just dot get. So employment status, the spellings are wrong. So employment status, property area, what's the spelling? Property area. Okay, educational level, I guess. Okay, loan purpose. Okay, let me just run this. This one is wrong, so it will be employer category. All right, so employer category, run this. Okay, right, now I will print the head again. So df.head, and here you could see there is no string values, and most importantly we have transformed this employment status into multiple values. So Here you could see employment status. What is that? Um, Employment status is salary, self-employed, and I think government, something like that, like personal. So here it's been changed up towards employment status salaried, self-employed, unemployed. Okay. Same for property areas, semi-urban, urban. Education level, not graduate, loan purpose car, loan purpose education, loan purpose home, loan purpose personal home, all these things. Okay. Now we need to show the correlation heat map, and which will help us to understand which are the most important feature or factor that affects the loan approval rate for a person. Okay. So first, let me create a new cell, and here we'll import Seaborn. Seaborn as SNS, and from matplotlib.pyplot. Sorry, it will be import matplotlib.pyplot as plt. Okay. First, I need to get a numerical column. So numeric df, I'll use df dot. I need to use select the data type. So select data types, and here I need to include all the data types that include integer 64 and float 64, right? So include, I'll be using simple float 64, and for safety purpose, even though we don't have any integer, but still integer 64. Okay. Then define our core values like correlation values. Then here I'll call my numerical df dot, call the function core, and then I need to use the loan approve because I need to get the relation of all the variable with this loan approve, right? Loan approve, and whatever the values that I'll get, I'll want to sort the values. Okay. So sort the values, and let's say make ascending false. All right. Then simple, I'll print it. So print the core, enter. See, so the loan approved, of course the relation of loan approved with loan approved will be the number one. So except the loan approved, credit score, applicant income, these are the most important, that matters the most, right? So these are the positive correlation, and these are the negative correlation, right? Now let me print the matrix. So for that, elt.figure, and first I need to make sure the how big I want to print it. So fixed size, the dimension 10.5. Okay. Then SNS dot, I'll call the heatmap, where I'll pass numeric tf. So numeric tf dot core, and then simple and not true, and cmap would be cool warm, and plot show. And this is just for the design purpose. And let me just add a title. Plot title should be, let's say, correlation heat map. Okay, enter. Yeah, see, this is a correlation heat map that is telling us that which are the features that related with the loan approval rate the most. Okay. All right. So before we split our data set into X train and Y, like train and test, let me first check the data set first. So here you could see we still have the loan approved in this same data set, but we need to segregate that, right? And that's why we need to drop this loan approved column, right? So I'll take a variable x where I'll use df.drop And to drop it is pretty easy. We'll first call the drop function, then we'll pass the name of the column that we want to drop, and then simple axis point. Okay, then same, and I'll keep that loan approved in my y variable. So in my x I have all the independent features, and in y I have the dependent feature like the loan approved. Now let me show the x. So these are the x, 27 column, and here let me show the y. I have only one column, and here we had how many column? This df have 28 columns. So in x I have 27, in y I have 1. Okay, all right. So now the thing I have to do, I need to split it, the data set, into train and test, right? So for that, what I'll do, simple xtrain. Okay, the first I need to import the train test split. So train test split. Okay, so xtrain will be needing x test, then we'll be needing y train, y test, right? Then I'll call the train test split will pass x, y, and I'll be keeping the test size 2 and the random state 42, and this test size 2 mean 20% of my row will be used for my testing purpose. So I am using 800 rows for training and 200 rows for the prediction, but it seems like a bit less, so let me just change it to 4. Okay, all right. It's saying that okay, there is an error. We had to import this from model selection, not pre-processing. Sorry. Okay, done. Now we have splitted the dataset within xtrain and xtest and ytrain and ytest, and now one of the important part is this feature scaling. Right now, if I have to tell you what is this feature scaling means, it's so feature scaling is a machine learning pre-processing technique that standardizes numerical features to a common scale, ensuring that features with different magnitudes don't unfairly influence the model performance. Now, what this means, you could see in this applicant income, it has this numerous values of income. Now, this 17,795 is significantly much higher than this 2,860. But the fact is, this differences of income doesn't really affect someone's loan approval rate, right? So we have to make sure that just because someone have a higher income, it doesn't make sense that he will be getting some extra leverage. That's why we need to standardize the whole value, right? And that's why we'll use this scaling. And let me show that. So we need to first import something. So from sklearn dot pre-processing, I need to import standard scalar. Okay, now simple thing, scalar variable, call the standard scalar function. Okay, then in my xtrain, let's say scaled, and here what I'll do, simply I'll call the variable scalar dot fit transform my xtrain, and for the xtest scaled I'll use scalar dot transform my xtest. Okay, let's run this. Now Now after that, if I simply showcase what this X-train scale look like, you see there is no like too huge of a difference. It will help our model to train much better rather than this number which have significantly differences among each other. Okay, so after that we need to import couple of libraries because now we need to train the model. So first we'll import sklearn dot from matrix. We'll import our accuracy score, confusion matrix, and classification report. Okay, then from sklearn dot svm, I need to import support vector classifier, and from sklearn dot linear model, I need to import logistic regression, and then from sklearn dot ensemble, I need to import random forest classifier. We don't need like Gaussian, naive Bayes, and KNN right now because we are only using SVM, logistic, and random forest. Okay. Now to train this model, first let us train the log model, like the logistic regression model. So log model, I'll call the function logistic regression. Logistic regression will pass the maximum iteration we want. So let's say I'm keeping it 1000, and I need to provide the random state. So random state, let's say for 42. Okay, then I need to fit it. So log model dot I'll fit with X train scaled and Y train. Okay, and see we didn't scale the Y because the Y only consists of 1 and 0, so we don't really need that. Done. Then we need to predict. So SVM prediction, here will pass the, sorry, not the SVM one. Okay, so now for the logistic prediction will pass the log model, and we'll call the function predict, and we'll simply pass xtest scaled, right? Let us run this. Okay, now simple for our SVM model, what we'll do, let's say SVM model, I'll call SVC. Okay, in SVC the parameters are kernel first, so I'll be using kernel, let's say RBF. You can use linear as per you wish. Then for the probability, I'll be make it true, and simple for random state, default 42. Okay, then our SVM model dot fit, and I'll simply pass X train scale and Y train. Okay, and simple SVM prediction, SVM model dot predict X test scale. Enter. Done. So now for this random forest classifier, what we'll do, RF model. So RF model will call the random forest classifier, and we'll first provide n estimators. And see, these hyperparameters are pretty important to know, and you can take help from internet for to know about all hyperparameters. Okay, and I'll be making a couple of videos on each of this model pretty soon to explain all those hyperparameters and how these parameters work, but I'm not explaining all the hyperparameters and all the theoretical concept in this video. I'll make a different video for all of these models. Okay, now RF model dot fit extend scaled Y train for prediction dot predict extra scaled, center. Okay, now we need to evaluate those models, and to evaluate, simple, we'll first keep all of them in a simple dictionary. So let's say logistic regression, right? Logistic regression, Here we'll pass y-test and logistic prediction, because we need to compare the values between y-test and logistic pair, like what the model have predicted and what are the values we had in the dataset, right? So same for our support vector machine and our random forest. Okay, and to keep that, I'll create an empty set. So accuracy scores empty. Okay, run it. Then to get all the values, what we need to do, simple, we'll run a loop for each and every these three models. So for model name of this y true and this y prediction, right? In the model start item, so it will be items, and then for the accuracy part, SCC, let me call the accuracy function accuracy score y true y pred, and we have accuracy scores model name with the same accuracy, and then we'll print some statements as, let's say, every model name with its accuracy, and also we need to print the confusion matrix. So confusion matrix, so confusion matrix of y true y pred, then classification report, all these things, finish it, and okay, let's run this. And here you could see in the output, logistic regression's accuracy is 0.84, mean it has the 84% of accuracy of predicting the values properly. And these are the confusion matrix, these are the classification report, and for SVM is 83, and for random forest is 89, right? So the highest amount of accuracy we are getting, and that is from random forest, right? So now we need to select the best model. And how we'll select the best model? It's pretty simple. Here we'll create a new variable as best model, and we'll use this max function to get accuracy scores with the key value of accuracy scores dot get. Okay, and this will give us the model which has the most amount of accuracy. Okay, enter. You could see best model for us is random forest, right? Now the last part that we have to do is to figure out the important feature that's affecting to figure out the output or the prediction, right? Now for that, we'll first create a feature as like a variable as importance, and in random forest we have this particular keyword or function as feature importance, which gives us all the important features. Then feature names x.column, we don't need that, by the way. Okay, so importance dot featured importance, that's it. Let me first run this, and if I just simple print this importance part, if I print this, you see these are the most important features. Okay, now to really make it in a proper frame, let's say importance df, like data frame pt dot data frame. So pt dot data frame, where we'll pass feature is x columns and importance of importance, right? And then we'll sort the values. So we'll sort the values with respect to the by importance. So by importance, and we'll make the ascending true, not false. Alright, done. Now if I simply print this importance df, you could see this DTI ratio have the highest, credit score is the second highest, applicant income is the third highest. Right, let me just use it to print the top 5. Okay, so that was for this video. In this video we have trained this loan approval prediction model with 3 main classification model as logistic, support vector machine, and random forest. Okay, so yeah, thanks for watching.